Hi everybody. This video is going to talk about graphing rational functions. So I want you to pause right now and I want you to copy down the steps that you see here and pay close attention to number 4 when we're talking about rules for horizontal asymptotes. Okay, now that you've got it all copied down, let's run through it really quick and then we're going to look at 2 examples here. Okay, so our goal here is taking a rational function and graphing it. Well, there's a lot of information we're going to be looking for, and typically we want to start by simplifying the function, so that would mean factoring, canceling out common factors. Okay, we're going to find the x-intercept by setting the numerator equal to 0, solving. Horizontal asymptote has all these rules, okay, but the vertical asymptote, we're just setting the denominator equal to 0, so that one's not too bad. When we're getting to the horizontal asymptote here, you're going to have to memorize these. So we're thinking of P as representing the degree or the biggest exponent of the numerator, and Q would be the denominator. So the degree of Q would be the biggest exponent in the denominator. So if the one on top is bigger than the one on bottom, there is no asymptote. If the one on top is less than the one on the bottom, it's y equals 0. And if they're the same, we're going to actually divide the leading coefficients of the numerator and denominator to get our equation for the asymptote. Okay. The 5th one deals with finding holes in the graph. And when we're talking about a hole, we're talking about a point that has literally been pulled out and removed from our curve, leaving a hole. It's a break in the graph. And those are going to occur when there is a common factor between the numerator and denominator that we actually cancel out. So if we find a common factor that cancels, that factor is going to correspond to the hole in the graph. So we need an x and a y value, right? It's a point, an ordered pair. So to find the x value, I spelled coordinate wrong, I just realized. To find the x value, we're just going to set that common factor that cancels equal to 0 and solve for x. To find y, we're going to take that x value we just found and we're going to plug it back into the simplified function, okay, the function that we get after we canceled out that common factor. So let's see an example here. Okay, we've got our function. Okay, factoring wise, my numerator could factor out a 2, which would leave me with an x minus 3, okay, and then that's over x minus 1. There is nothing that cancels, so we don't have to leave it in factored form, but we can. It's not a big deal. So let's go through and find our information. So to find the x-intercept, I'm going to take that numerator, set it equal to 0, and solve for x. Well, if I set x minus 3 equal to 0 and solve, I'm going to get positive 3. Okay, that's the x value that will make my numerator 0, so that's my x-intercept. Vertical asymptote, we set the denominator equal to 0. So if I set x minus 1 equal to 0 and solve, I'm going to get x equals 1. And remember, vertical asymptote, we need to write it as a vertical line, so it has to be x equals. Now, for the horizontal asymptote, we need to look at the degrees of the numerator and the denominator. The degree of the numerator is 1 because I have x to the first power. The degree of the denominator is also 1. So this is the one where we divide the leading coefficients of the numerator and denominator. Well, the leading coefficient of the numerator is 2, and in the denominator it's a 1. So if I divide 2 by 1, I get y equals 2 for my horizontal asymptote. Now, there is no hole because there was no common factor that canceled out. So let's go ahead, let's plug this into our calculator, let's look at the table, find the points, and plot what we can. Okay, there are going to be a lot of decimals. Typically, before you even start plotting points from the table, I like to sketch in the horizontal asymptote and the vertical asymptote on my coordinate plane here. We also already know a point because we found the x-intercept, so I'm going to go ahead and plot that as well. So I'm just going to plot all the ones that I can, the ones that are relatively nice. So I'm going to plot negative 9, 2.4. I'm going to plot negative 7, 2.5. negative 3, negative 3, positive 3, negative 1, 4, and 0, 6. Now, if you look at the actual graph on your calculator, you're going to notice that the graph is actually broken into two parts. Okay, those vertical and horizontal asymptotes are kind of breaking our coordinate plane into quadrants here, and our graph is going to appear in two different corners, if you want to think about it like that, on our coordinate plane. So then in the other side, okay, my curve is going to be where we have this x-intercept plotted. So let's get some other points here. We've got 2, negative 2. We already have our x-intercept, 5, 1. And then I'm going to do a 9, 1.5. So here is our final graph hugging along those asymptotes. Now, for the domain and range, it's actually not that bad. It's going to be all real numbers except for the x values and y values where we have asymptotes and holes. So for us, the only x value that is excluded from our domain, so I'll use the does not equal symbol. The only x value that's excluded is 1, right? That's our vertical asymptote. The only y value that's excluded is 2. So let's look at one more real quick here. Okay, so let's start by factoring. My denominator is going to factor into x plus 5 times x plus 4. So this time we have a common factor that cancels out. So that's an indicator to you that there is going to be a hole. Now our simplified function is going to be f of x equals 1 over x plus 4. So this is what we're looking at to find all of the other information. Now for my x-intercept, when I set that numerator equal to 0, I just get 1 equals 0. There is no x to solve for, so there is no x-intercept. Vertical asymptote, we set the denominator equal to 0, so x plus 4 equals 0 will give us x equals negative 4. For the vertical asymptote, if you look at the numerator here of our simplified function, the degree would be 0 because there is no variable. The degree of the denominator is 1. So if the degree of the numerator is smaller than the degree of the denominator, if we look back to those rules, it says the horizontal asymptote is automatically y equals 0. So let's work on finding this hole. Okay, let's find the x value first. To find the x value, we're going to take that x plus 5, the common factor that canceled, set it equal to 0, and solve for x. Okay, so there's our x value of the hole. To find the y value, I'm going to plug it into my simplified function. So I'm going to evaluate the function at negative 5. So I get 1 over negative 1, which means my y value of the hole is negative 1. So let's go ahead, let's sketch our asymptotes. Let's put an open circle where this hole is, and then we will go to our calculators and get some more points. So there's my horizontal asymptote. Here's my vertical asymptote. My hole is at negative 5, negative 1. I'm going to put an open circle there. Okay, so let's plot the other points that are relatively nice. I'm going to do negative 9, negative 0.2, so very close to the asymptote there. Negative 6, negative 0.5. And that's about all we can squeeze in over here. So our graph is going to be hugging right along the asymptotes. Okay, we've got our hole there, we've got that break in the graph. So here's the first piece. Okay, and then if we plot some more points, we're going to find where that second part of the graph is. So we've got a point at negative 3, 1. And we've got a point at negative 2, 0.5. And you could find some more points and you could plot some more, but there are a lot of decimals for this one. There are not very many nice points to plot. Just do your best when you're graphing. Make it as pretty as possible. And there we have it. So this time, our domain, we have two x values that we need to exclude from the domain. Okay, we can't have an x value at -4, that's the vertical asymptote, or at -5 because that's where the hole is. That point has been extracted, it's been removed from the curve. For the y values, we're going to remove 0 because that's our horizontal asymptote, and -5, which is the y, or I'm sorry, not -5, -1, because that is the y value at the location of the hole. All right, I know that's a lot of information, but that is it for this video. We'll have lots of practice. Have a wonderful rest of your day.